Okay, I think we are in business here. All right, so where we left off, we were doing the desk here, and we had material parameters that we'd created for the valance, for the desk surface, and for the pipes. Now, the reason we put those material parameters on is so at the bottom here, when we switch to realistic mode, now at this point, we're not going to see any materials. Everything's just going to appear gray. But if we select our desk now and we go into the type properties of our in-place family, so we're not having to edit it, we can simply go to edit type. So this is like editing any other regular family that you might bring into your project. Now you folks can see we've got those 3 different material parameters there that we can now adjust. So what I'm going to do is I'm going to make the counter material concrete. So I'll just click inside here and I'm going to load up my materials for my project. Remember, this is an in-place family, so we've got all the materials of the project that we can draw upon to change the appearance of the desk. Okay, so I'm just going to put concrete into the material list at the top. So I'll just do lightweight concrete. Now this has a rendered appearance as well. Now we're going to be talking about rendering later on in the course. But now this appearance, concrete, is going to be given to the top of our desk. So when I hit OK here, you'll now notice in realistic mode that we've got concrete for the top of the desk. So again, I pick my desk and I'm going into its type property. So you could do this with a door or a window. You know, you're going to change the material parameters. So the counter, we've made concrete. The valance, let's see if we can find a nice wood product. So here I go into the materials list. Now notice I'm not going to add a material parameter to it. I'm just going to go into the materials list. So once you put your cursor inside one of these material rows, you hit the little button that takes you to your list of project materials. Now maybe oh whoops, not concrete. Alright, so I'll just put wood at the top here and I'll choose one of the wood materials, so I'll choose cherry and hit OK. And then for the bars, I'd like them to be like a stainless steel or aluminum. So again, I put my cursor in that row now, and because we've added a material parameter for this, I can now go into Revit's material list and I'll choose stainless. So there we go, stainless steel. Hit OK and OK. And now you guys can see that we've got all of that goodness there from those material parameters that we created for this desk. So that is why we add those material parameters that are in there. Now we are going to move on here. Now I'm going to leave this this in-place family in here. Folks, if you want to turn over the page to page 3. So let's go through this example together. Now we mentioned that with your in-place families you can bring in geometry from other programs. We're going to bring geometry in from Sketchup. So if you've modeled something in Sketchup, you can bring it in and use it as Revit geometry. So what we need to do is go to our south elevation. So the first thing it asks on page 3 is create a story called roof 20 feet above level 1. So finish your in-place family so you can go back out and see the regular Revit interface and go double click on the south elevation, and from the architecture tab here we're going to use the level command, and starting from the left and going over to the right, add that next level in, and we're going to rename it roof. And I'm going to spell that right. So now we've got a roof level. Enter the plan view of that story. So there we go. Now, we can't see down to the desk, right? And that's because of our view range. So if I wanted to be able to look right down to my first floor, I need to go into my view range in my roof plan view and change the bottom and my view depth so that it's down to level 1 so that I can see that desk there. So that is view range. So when you go into your roof plan, go find the view range feature, edit it, and change your bottom level and your view depth to level 1. So that's often something that gets forgotten about in Revit projects. So now we can see the desk in this view. Now, I need to grab a file from our folder tonight. So if you folks go into the Session 8 folder, you're going to find a Sketchup file, which I have to download from BCIT here, so I just got to log in and grab it. So if you folks go to BLDG and then 2805 and then Session 4. So this is on the J drive for you, so find the share out drive, BLDG 2805 Session 4. Inside there you're going to find Sketchup Roof. So you'll need that in the next step. So I just got to download it to my computer here. So what I'm going to do is I'm going to start an in-place roof family. So Architecture tab, Component, Model in Place. Just like we did with that desk. So this time we're going to choose Roof category. And hit OK. So I think it says call it SketchUp Roof. SketchUp Roof. So we're giving this family a name. So make sure you are in the Inplace family before proceeding further. If you need help with that, just wave at me and I'll get you sorted. So we can either use the regular modeling tools here, or we can now bring in geometry on the Insert tab. So now we can import geometry from SketchUp or from some other program. So go to Import CAD. Now what you're going to have to do, it's in AutoCAD format right now. You need to switch to the SketchUp file format, and notice it'll bring in something from Rhino or ACES, which is a generic solid modeling file format, which pretty much everything makes. So we're going to switch to SketchUp. So you're going to need to import that geometry. So if you haven't copied it already, just go, once you switch to SketchUp here, you're going to have to, in your folder here, you're going to have to switch to the share out drive, J, the J drive, and then BLDG 2805 Session 4. And you'll find the SketchUp Roof inside it, and just bring it in. Oh, that's great. Import CAD. Why? Okay, you know what? Just give me a second here. I'm just going to switch back to the BCIT computer here and do it here. I don't know why my computer here won't do it. Maybe something about the file got messed up. So you folks should be able to import it, no problem. you can't see what I'm doing because I'm not up on that monitor. Okay, so just give me a second here. I'm going to get this sorted. Okay, all right. So just a sec here. Okay, so now at this step, I thought I had just downloaded this. Just a second here. Sorry folks, this is really boring. Let's try this again. Okay, good. All right, so what you folks should see in your roof plan is something like this. You will see the SketchUp geometry that's been imported. Unpin it. You'll see that it's pinned initially. Unpin it and center it so it's right over top of your reception desk. We're going to put curtain wall around this thing. So you should see this geometry, and it should be within your in-place family. So you'll know that you've imported it correctly. One common mistake that people do is they forget to start the in-place family before they import this geometry from SketchUp. You've got to have started the in-place family first before you bring this thing in. Now that this is done, if we look at it in 3D, you can see the shape from SketchUp here. And you'll see that you can now finish the model. All right, now that this is done in your roof plan, now we might not be able to see the geometry because it's above our view range, but in the site plan, you will be able to see our roof, and when you put your cursor over it, Revit will tell you that it is a roof family. So it's an in-place family that's using SketchUp geometry that Revit will treat as its own geometry. So what I'm going to do now is I'm going to switch to Wireframe so I can see through my roof. There it is there. And what I'm going to do is I am going to go to the Architecture tab, and using the Wall command, I'm going to choose from my curtain wall tools here, I'm going to choose Storefront. And if you guys just want to draw some storefront walls underneath the roof, we'll see that we can connect them up to the roof. So here I'm just using the arc tool to create some curved curtain wall. Just like I did before. So what I'm showing is that we can connect curved geometry from our curtain wall up to a complex roof form. So I'm in Wireframe right now in the site plan Wireframe here, so I can see through my roof, so I can confirm the shape of these curtain walls that I'm drawing. And now when I go to 3D, I can see my walls underneath. And just like I did before, I'm going to put my cursor over one of my curtain walls and use the hover tab click thing that Revit does. So hover over one wall, tab key once, and now left click. So all of my perimeter walls are selected. So now that they're all selected, I can go up and hit the attach button and pick the edge of my roof, and it's going to attach those curtain walls up. So again, I'm going to get that error because Revit's going to have to delete these mullions at this height to extend the glass upwards. So now that that's done, we can see that our curtain wall follows the shape of this Inplace family. So the point of this, of course, is to show that you can use geometry from other programs in Revit in an Inplace family. Now I'm going to skip the next little exercise here for the trellis modeling, just so we can focus the rest of our time on massing. So I'm going to close this down here. So this file, when you're done, folks, I believe you're supposed to hand it in. So in the bottom page 3 there, you can see save the project in as your last name, Inplace model in your folder on the iDrive, on the share-in drive. So you can do that before next week. Okay, so what we're going to look at tonight are the massing tools. Now, Revit's massing tools have a number of applications, some of them quite practical, and some of them not so much. Now, if we look at, I'm just Google imaging Revit massing. Now, the reason is to show you the kind of work that is being done with Revit's massing toolset. If I can describe or use one word to describe what Revit's massing toolset is about, it's about creating form. And it's about, again, about getting outside of that linear and rectilinear box that Revit is in if you use the regular tools that you find in your everyday Revit project. So even just as I scroll down here, you can see some of the different shapes that can be built, and there really is some amazing work that's being done with the Revit massing tool system. Now, one of the blogs out there that's just fantastic for great stuff that's being done in Revit is the Builds blog. You can see I've got it spelled up there. It's the regular word build, and just tack a Z on the end and Google that, and it will take you to the Builds blog. So this is the website of Zach Cron, who is one of the product designers for Revit and for the massing tools. And this blog has a series of stuff. Now, he hasn't been keeping it up for a couple of years, but it's a really good repository of the different applications for Revit's massing tools. And we're going to go over 3 of them tonight. Now, for those of you who are into form exploration, there is a modeling environment in Revit which is dedicated strictly to work in the massing tools. Here's how you get at it. So from the File menu, when you hover over New, so you just click on File and then hover over New, don't click it, there is the Conceptual Mass family. Now this is a bit of an oddball. When you open it up, you have to click Mass and hit Open. Now once you've done that, this is the environment that you're presented with. It's a very strange environment. Now you'll notice up on top that the regular Revit tools aren't there. In fact, it looks a lot like the Inplace family that we were working on a few moments ago. So again, go to the File menu, hover over New, choose Conceptual Mass, hit Mass, and hit Open. So this is the Conceptual Mass environment. This is the place where you can do form exploration at the macro level. The idea is that this is used to play with forms for the entire shape of a building. Now you notice that we have the views in the project browser. So we have our elevation views, and we have our plan views, and we have our 3D views. So the idea with this environment is that just like you would in a regular project, you would add levels to your project. So if you're doing a 30-story building, you would draw in those levels. So here I'll just use the copy command and just using a copy command and copying up a bunch of levels. Now I don't mean for you to sort of follow along here, but you see I've made these levels in elevation. We're used to seeing that. But what you're not used to seeing is this. When you go back to 3D in the Conceptual Mass environment, every level that you create appears in the 3D view. Weird, eh? And watch what happens when you orbit. It shows those levels kind of at the back, like there's this invisible box that has the levels just printed on the inside of the box. So the idea being that you can start to create forms on each one of the different stories of your building, and this can be used to generate a shape for the building. Now, just watch up here. I'm going to go through this process and explain to you what's going on. Those of you who've used SketchUp, this is very similar to SketchUp in terms of how SketchUp builds things. So what you do is I'll just draw a rectangle here, and it's on this one story. Now, I can switch to a different story using the Set Work Plane tool. So I can pick this top level in 3D, and now again draw another form, like this rectangle. And you can see that they are on two separate floors. Now what I can do, and this is the part that's kind of like SketchUp, you see when you put your cursor over it, it wants to grab the whole thing. So I pick one set of lines, hold down the Control key, pick another set of lines, and now I can create a form in between them. So now I get this shape. This shape is incredibly plastic. So there I just grabbed an edge and I stretched it up. Not only can you just grab an edge, you can grab a vertex and stretch it up. So what you can really create here are some very obviously expensive geometries to construct. But the idea is that on a very macro level, you can start playing with the shape of a building. So now I'm just going to throw an ellipse on the bottom floor of my building, and I'm going to have that ellipse come through and just intersect through everything else that I'm doing here. So all I need to do now is select that bottom ellipse, create form, and it creates this shape that I can extrude upwards. So now I can use the join geometry tool to merge these pieces together. So now I'm creating the volume of a whole building. Now, what do I do with this? Once I'm satisfied with what I've modeled here, I can import this into a project. So the idea is that you can cut your designers loose to make some very expensive and crazy shape for your office, and then this can be imported into a Revit project and then further geometric work done with it using these forms as a guide for the overall shape of the building. So there are, when you're creating these shapes, you can do voids and solids. So here's a shape, but this time when I create it, instead of creating a form, I'm going to create a void form. So initially here, when I did the create form, it creates a solid, but now I can create a void. Would be helpful if I put it somewhere near my building. So here I'll just use the move command to move it into place. So you can see how it's automatically inferencing those levels down below. So now I've got this void that's sitting here, and I can ask Revit to do the cut geometry tool to intersect a solid and a void. Now we're going to be doing this later on tonight, so you'll have a chance to do it. So now that I've got this final shape, I can import this into a project and use it to build curtain walls. So I can add curtain walls onto these different faces and roofs and floors and all that sort of thing. Now, again, this is a separate modeling environment. It's not done in the context of a project, but it can be imported into a project and used in that manner. So there are firms around the world that do massing studies here inside this environment, outside the context of a regular project. All of these tools that we saw here are actually available to you inside a project. So what I can get you folks to do is just to drop down to the Revit desktop again and choose the architectural template. So clear everything off your screen, save your work, and then start up the architectural template. So looking at page 6 of the notes, you can use the conceptual mass environment to build massing, or you can do it as an in-place mass family. So that's what we're going to look at next. All right, so from the component drop-down, we're going to choose Model in Place. So that's one way that you can get at it. There's another way, it's mentioned in the notes. You can do it from the Massing and Site tab as well. So this time, instead of choosing casework or roof or what have you, we are going to choose Mass. Now, by default, Revit has the mass category turned off in every new view that you create. So to illustrate here, so just like last time, remember you choose the category and then you give it a name. I'm not going to bother, I'll just leave it as Mass 1. But that dialog box that you saw warning you that massing is now visible, this is because when I go to my visibility, VV, every single view in Revit has massing turned off by default. The idea with massing is that it is there as a guide in the background, helping you create the form of your building. It's like a skeleton that you build on that you don't need to see. So that's by default, it's turned off. Now, while you are working in massing mode, Revit turns on massing, and if you go to the Massing and Site tab later, we'll see how you can turn it on by default. So here we are inside the massing system. Now if we look up on the ribbon here, you can see that there's a tool palette full of tools so that we can draw a 2D shape that can be then turned into geometry that will build our massing form. So just pick a rectangle tool on level 1 and just draw a rectangle on your screen. Now if you go to level 2, you can see the rectangle that you've drawn earlier in the background. Draw another rectangle on the screen that's a different shape or a different size. So what these are lines that will create the mass form. So they are 3D lines. If you go to 3D and orbit around, you can see those two sets of lines, and that they are on different planes. And so what we're going to do now is what I showed you earlier. Just hit escape a couple of times so that you're not drawing lines anymore. And you'll notice curiously, if you put your cursor over one of the sets of lines, Revit wants to select the whole thing. Okay, fine, select it. Now hold down your control key and pick the other lines. So now all of those lines are selected. Up to the Create Form tool, and now we have our form. Now if you remember from the conceptual massing environment, the mass form there was solid. This one is transparent. So the idea is that when you're using these mass forms in your project, Revit does not want the mass form to hide anything else that you've modeled. The idea is that you can see through this form to anything else that's been built inside the project. Now, just like before, while you're in the massing environment, you can put your cursor over a plane. So here, if I hit the Tab key, it will eventually select that plane. So if I click it now, I can drag that plane up and down to stretch it up. So just keep on hitting the Tab key until you get a plane selected, and then you can push-pull that plane. So there's that plane again being selected. I can also just pick one single line, and I can move that line up and down. And I can also put my cursor over a vertex and hit the Tab key until I get that little, it's actually a big blue dot. And when I select it, now I can move that one vertex around. So you're beginning to create something here that, you know, Zaha Hadid would be proud of. I was just reading her biography. I didn't realize that her instructors at architecture school said that she's the inventor of the 89-degree angle. I thought that was pretty funny. So here what we're doing is we are creating some fun geometry here. So the purpose of this is that this is the skin onto which we can place our walls. Now, a regular Revit wall can't hope to create this kind of geometry. But when we are done, you will see that that's exactly what we're going to be able to do. So up on the ribbon, choose Finish Mass. And maybe just go to one of your elevations, and you can see how many different levels that you've created already. Now, one of the nice things about the massing tool set is that it can be used early on to do a yield analysis for your building. It'll tell you how much square footage your building is going to be. So this mass, when you select it now, so when you leave your in-place massing mode and you come back and you select it, you'll see that there's a mode here, Mass Floors. So any levels that you've created in your project that intersect or that pass through our massing here, so I'm just going to add a couple more levels. So again, when you select a mass object, you're going to see this tool up on the ribbon, Mass Floors. So now I can select all the levels that pass through, that intersect that object, and hit OK. Now, it doesn't look like anything's changed here, but when you go back and look at it in 3D, look at this. You guys see those things that just got added? Those little floor plates got added to this mass form. And now when you select the mass form, have a look. Gross floor area, 6,900 square feet. So these massing forms can be used to build a shape, and then you can kind of get a rough idea of how much square footage you're going to get out of this thing. And of course you can go back and edit the mass model. So now we can continue to play with its size. And when we're done, Revit will tell us how much floor area we're going to get now. So it was 6,900 square feet. Now it's 8,700. So kind of a nice way to do, you know, extrude up a tower and build a podium. And now it's going to tell you, you know, how much square footage on a very rough level you can hope to get out of it. So this is called Building Maker. And if you were to Google Revit Building Maker, it would take you through this process. Now, I mentioned that Revit can now put its own wall objects onto this shape. Now I'm going to turn on shading here. So you can kind of see that that's a rotating, twisting plane there. So now if I grab the wall tool, your wall, roof, and floor tools all have the by face option. So there's wall by face, roof by face, and floor by face. So this means by face of a massing object. So if I use the wall by face tool, I can choose one of my everyday Revit walls here. Beefus on metal stud. And all I have to do is pick a face of my mass object and I get a wall there. Now that mottled appearance that you are seeing is just because the wall object and the mass object are in exactly the same plane. Now you put your walls on, you put your roofs on, and then when you're done, on the Massing and Site tab, see here, this is what Revit was talking about, show mass and floor. So as soon as you start using the mass modeling tools, Revit turns this on, show mass, form, and floors. Now the default setting is for Revit to use whatever's in your visibility settings. So if I go to my visibility settings here and I go down to mass, it's turned on. If I turn it off now, you can see that mottled appearance goes away. So the idea is that you can use the mass form to put on some funky walls like this, and then we can, you know, throw some windows and doors in it, and the windows will, you know, punch right through the wall, and we can put a door here at the bottom level. And so as far as Revit is concerned, that's just a regular old wall with some windows on it. And that's kind of the idea, one workflow behind the massing tool set. So that's to create walls that you can then skin onto this form. Now, what happens if the massing form changes? So if you decide, hey, you know what, we want to tweak the shape of this building a little bit. So I'm just going to turn the massing category back on. And that kind of weird mottled shape comes back. So it's just like an in-place family. We'll put our cursor over the edge of it here, so we might have to tab to get it selected. Now I'll have a look down on the status bar here and also on my cursor. So I'm hovering, one tap of the tab key, there's our mass. So now we can click it and choose edit in place. So it's just like an edit, it's like an in-place family. So now if I make some more changes here, maybe pull up on this line a little bit, and when I finish, you can see that the wall and the massing are out of sync. So what Revit wants you to do is select those walls afterwards, or roofs or floors, and hit update to face, and Revit stretches everything back out to suit. So it doesn't do it automatically. You have to finish your mass edits and then come back out afterwards and reassociate your geometry with any changes that you've made in the mass model. And then when the massing work is done, you go down and turn the mass category off, and you're good to go. So that is one of the more significant uses of the massing workflow. So if you guys look at page 6 of the notes, yeah, you're just creating, so what can happen is that you've built a form that's so sharp that Revit can't resolve it with the regular wall tools. Yeah. So you have to be careful when you're working with these massing tools, because you can end up building shapes that Revit will have trouble, you know, when you're putting the wall by face on it, you might not get the results that you want. Now, that was workflow number 3. What I'm going to do here, folks, is I'm actually going to delete all these windows and walls. I'm going to keep the mass form. So I'm just going to turn it back on. We're going to talk about panelizing. Now I'm not going to spend a whole lot of time on this because this is definitely its own course. The next part that I'm going to talk about here is quite complicated. So page 6, massing workflow. Let's look at steps 1 and 2. We create the form, which we've done. Now we're going to look at dividing surfaces. Now, when we went back and looked at the Revit massing in Google Images, what you're seeing in a lot of these pictures is where there's panelizing happening of the shape. Now you folks can see we've got this organic surface, this sinuous shape, and you can see how there are lines that sort of follow longitudinally, and there's other lines that cross over the form. So this form has been panelized. It's been assigned a grid work. Same with this one here. Now, what these tools can be used for is to build space frames. So just like you've seen down at the Plaza of Nations and other parts around town, you can create a shape, and of course building with triangles or rhomboids, you can cover it with glass. So you just run a series of mullions in both directions and you glaze it up and away you go. So now what we can do, and I've deleted all my walls as you've seen, I'm going to go back and go back into my mass model, and you'll notice that when I edit my mass model that Revit hides my mass floors just so they don't get in the way. Now we're going to talk about panelizing. Now this is an unpanelized shape. Now if you're going to choose any face, put your cursor over any face, you will see divide surface. So this is where Revit creates what's called a U and a V grid, and they roughly correspond to X and Y. So when you do this, Revit creates a grid on the face of your mass. So it's a U and a V grid. So you can see there's a U grid number here, so I can change the number of horizontals. And here my verticals are the V grid. So if I change my number of verticals here down to 6, it's going to reduce the number of verticals. So there you go. Now into each one of these grid locations, Revit can insert a panel of a geometric shape that you choose. Now most typically on panelized surfaces we do triangles, which can make any shape. If you folks have ever been out to City Square out in Surrey, that's the tower that Bing Tom did. There's a curved part right at the point. Just when you get off the station and you walk up to the building, there's a curved point. As you look up, you can see that that point of the building twists as it goes up. And the curtain wall is triangulated so that twist is easily taken care of. Not easily, I suppose. I'm sure it was quite a lot of money, but it's easily done from a geometric perspective. Now, once a face of your mass has been panelized, you'll see in the Properties palette here that it says no pattern. Now, as soon as you hit the Properties palette here, it's going to show you all of the different methods of panelization that are used on building faces. So like I said, the most common are rhomboids and triangles. So if we're going to do, say, a flat triangle, so everything's right at the face, we click this, and now this shape, it becomes opaque, and it shows a series of triangles. Now what this is meant to do is to be sort of like a placeholder, I guess, to show you how this face would be panelized. Now you can choose what will actually happen with these panels. So that's the triangular pattern. Now maybe along the lines you would have tubes, and then in between the tubes you would have glass. Now here's how it works. Once a face has been triangulated or panelized, so here if I go back to the top and I choose no pattern, so there's my basic U and V grid. So that's how many triangles would be placed in each direction. So again, click the face, and you can choose which system is going to be used. Now there are special families in Revit that are called pattern-based curtain panel families. Pattern-based curtain panel. And in our folder for tonight, in session 4, there's a few of them. So here is one of these special curtain-based or pattern-based curtain panel families, and I'm just going to download that to my computer here. Now, I used to teach a little bit about this in the course, but it was a little bit too much for most people to handle. So I'm just going to show you how you can load these things in and how they're used. So there's the family that I just downloaded. It's in the session 4 folder. And I'm just going to drop that into my project. Okay, so that was the triangle family. Now, what happens when you've got one of these special families in, so a pattern-based curtain panel family, when you're inside editing your mass family and you go on a face that's been panelized, so this face here has not been panelized, so I can panelize it if I want. So now it's panelized as well. And now I will change the number of horizontal and vertical faces to 6 each. So again, once you panelized one of these surfaces, you can download one of these pattern curtain panel families that's meant to go on the outside of a building. It's like a space frame grid system. And now you'll notice, because I've loaded that triangle family in, that under the triangle section here, where it's listing all the different kinds of patterns that you can put onto the face of your massing, that it also shows this family. So now what happens is, here on this face, we're going to get those triangular pieces put in. So I'll put that on the other side here too. This is very computationally intensive stuff. And so it's creating all the tubes there on the outside of the building. So I know a friend of mine works for a high-tech curtain wall company, and they do stuff like this in their sleep. Very easy for them to pull off a shape like this. And they really like Revit's massing tools, because it really, they say it's very easy for them to take this and turn it into something that can be constructed. So these special families, these curtain-based, panel-based curtain panel families, you can find them online. I've got a few of them in that folder, and so they are used in the massing environment. So when we go back and look at page 6 of the notes, we create the forms like what we've done, and then we apply patterns to each face, and then we choose one of these pre-loaded pattern families that are typically mullions and glass, not always, to put on the face of the building, then the face of the massing form. So once this is done, you can see the mass floors come back, but even here, so I'm just going down to my mass here. So even when I'm done and I've turned the mass off, you can see that our pattern families are still there. So the only way that you can modify the extent or the shape of these curtain panels is by going back and editing the mass form again. So this is workflow number 2 that can be done with these. So again, this is another big bucks workflow. Okay, let's go to page 7. So now you guys get a chance to do this for yourself, and we'll talk about these forms in greater detail and the tool set inside the massing environment in more detail. Okay, page 7 of the notes. So as we've shown, you build with a series of model lines on different work planes, and then you build a form in between them. So you've got, you know, a shape that you've drawn, and after that's done you choose either a solid form or a void form that will be created out of your what was initially just a set of lines in whatever shape you choose. Now you'll also notice that there is another category here called reference lines. Now these are quite different. The model lines are just black and they look rather garden variety. With the reference option, they look quite different. They're green and they're dashed. So you'll notice here I'm just drawing some reference lines. So go ahead with yourself, draw some reference lines inside your massing family, and just draw, you know, a few of them, and then stop, and then when you're done, go back to modify mode and click one of them. Looks quite different. So the important difference between these model lines here and reference lines is what happens to them when you build a mass form from them. Now, you can build multiple sets of reference geometry, stack them up on different stories, and build a mass form from them, just as you can do with your model lines. But here's the difference. Watch what happens when I click my model lines and I choose create form. Now, what happens to those original model lines? They are gone. They are subsumed, they are absorbed into this mass. On the other hand, when I hover over my reference lines, which create all these dashed planes, which I shall explain momentarily, when I select these ones and hit create form, I can create a surface or a solid. Now this is interesting. This is not an option available to you when you use model lines. Now I'm going to create a solid this time. Those reference lines are still there. Put my cursor over it. Look, they're still there. These are the original reference lines that were there when I created this thing. Whereas with my other massing form over here, this line here is not the same one that I had before. So what's the big deal? I would recommend, if you're using the massing workflow and you're building forms for a building, that you use reference lines as the basis for your mass building. Now why is that? That's because this geometry gets preserved. So if I start stretching these lines around now, you can see it's going to update my mass form. And often when we build the skin on the outside of a building, these lines are in very specific locations. They're often representing the top of a slab, and they're used to create a very specific skin on the outside of a building. And so if I decide, you know what, I kind of want to go in a different direction with this stuff, but I want to keep my original layout geometry for my massing. Here, if I tab select, I can nuke my massing, and it keeps the original structure, these reference lines that I build. Whereas if I go over here and I tab select my mass that was made from model lines, and I delete it, that original geometry is gone. So when I'm working with firms to help them do towers with massing, I will recommend that we do it with these reference lines that are preserved no matter what we do. And if we want to change the shape of the massing, we go find our reference lines on each story of the project where we want the massing articulated from, and we move these reference lines around and the massing updates. So you'll notice here that if I try to tab select one of the faces of this mass, I can't. I can grab its top, I can change its height, but that's all I can do. Otherwise, the shape of this massing is still going to be completely driven by this set of reference lines. Now, of course, you can build, and we're going to see this in a moment, you can build a mass form out of several sets of these massing lines that can be stacked at different heights. So if you want a building that kind of bulges out and then comes back in again, you can do that by stacking reference lines at different heights in your model. So instead of reference lines that are stacked vertically, we're going to see how we can draw reference lines in plan and build a form that spans those spans between those reference lines. So you see that when I drew, or when I erased those reference lines now, it deleted the mass as well. So that mass, if it was created initially with reference lines to create the form, if those reference lines are deleted, the form also is deleted. Okay, folks, here's what we're going to do. We're going to show now how you can use those reference lines in plan to create geometry that's hosted on those reference planes to create what we call lofted geometry. So, go into 3D. It's the easiest way to draw this. So go up to your View tab and choose the default 3D button. And no matter what you draw in there, you can just preserve it. You don't need to get rid of anything at this point. And we're going to go to the Create tab, and we're going to use Reference Geometry. And we're just going to draw 3 reference lines, and then we'll talk about them. And make sure that they diverge. So you're going to draw 3 separate reference lines that diverge. And once you're done, hit Escape once, and we will explain these different reference planes. Okay, so what's happening here is that when you draw a reference line, it's actually got 4 different working planes that you can use to put geometry on. There is a horizontal working plane along its length, there's a vertical one, and there's ones at the ends. So when you select one of these reference lines, you can see all these different work planes that you can build stuff on. Now, the purpose of a reference plane, a reference line rather, so this is different from a reference plane. The idea with reference lines is that they hinge really nicely around their endpoints. Now, if you ever wanted to model an operable window, which we will do in a couple of weeks, it's really nice if you can make that, if you want to make that window open, the best way to do it is to use a reference line, and the geometry that you would build for the vent of your window would live on the vertical work plane of this reference line. So that's why the developers put these special objects into play. So what we're going to do is we are going to use the vertical working planes of the 3 reference lines and put geometry on each of them. So with these reference lines sitting here, we're going to use the set work plane tool, and I'll show you what we'll do here. Now usually with the set work plane tool we have a named reference plane, so we've been talking about that earlier, but you can also do it visually. So with the set work plane tool you can put your cursor over one of those reference lines and you can see how it sets, or it's going to pick one of those planes. Now if I use the set work plane tool and just hover over that reference line, I can hit the tab key and I can choose which one of those I want to work with. So I'm going to work with the vertical plane here. So now when I hit show, you can see that that is where my next bit of geometry is going to be placed, and I'm going to draw an ellipse on this work plane. So there's an ellipse. Oh, I want to do it with reference geometry as well, so I'll choose reference first and then ellipse. So now a reference ellipse will be drawn on that work plane. Now I'm going to draw 2 more. Now the nice thing is that Revit keeps you in drawing mode even as I go to the set work plane tool and bring my cursor down over the next reference line. So I hover over it, hit the tab key once to get that vertical work plane. You can see that the show work plane tool highlights that other reference line, and I'll just draw another ellipse here as well. I'm just trying to do this kind of freehand here, so it's so hover, tab, and drawing yet another ellipse in this location. So I've got three ellipses on different in different locations. And so what I can do now is I can control click those 3 ellipses to create a form. So click, control click, control click, and with those 3 ellipses selected, you folks can see up on the ribbon, create form. So now it creates this shape in between them. And now that we've got this shape on top of them, we could skin a roof object onto it if we wanted to, or we could panelize it and put in curtain panels, so basically glass panels that would mold to this shape. Obviously this is sort of free-form architecture that you're rarely going to find a need to do this kind of geometry in Revit unless you're doing a design thesis or you've got a client with very deep pockets. Now let's also look at some of the other tools that are available to you here. We've talked about the difference between model and reference geometry. Most of these tools that are in here, you probably understand their purpose. There's splines, there's fit splines, and there's spline through points. So those are kind of like Bezier curves and that sort of thing. But there's also a point tool. Now, what this point tool does is it creates one of these little purple points in here. And you can put these at different points in your model. And during the massing process, you can move these points around so that you can move them to a different X, Y, and Z location. So you can see it when you select them, you can move them around. Now what these are meant to be is like anchors. If you're building geometry in space and you need some points that can be used as starting points for maybe modeling a 3D path, so even doing for something like pipes or you know, a roller coaster, if you're trying to model that sort of thing. Once these points have been located in space, you can create splines and model them so they pass through these points. So these can give you freedom to pass through space on a three-dimensional level. So what I've used these points for is for doing something like what I'm doing right now, where I want to create a spline that passes through those points and then create a structure that follows that path. Now this again is going beyond the realm of most of the budgets that we would see used by architects locally. So I just wanted to point out what those tools were for, and talk about the processes there too. So in page 7 under possible processes, these reference points can be used as points of reference for other massing work that you do. Now we've done the lofted form that we're talking about on page 8. Now that triangle family that you saw earlier that I loaded in and put into and made that curtain wall around the side here, so that family that you see here is based on a curtain panel template. So that's mentioned on the top of page 9. I don't want to get into that right now because a lot of what we talked about here is confusing enough. And what I want to do is get on to a more practical application for the massing tools, ones that you could quite probably find a use for, you know, at least once a month or so in your work. So page 9, massing and building maker at the bottom, we walked through that earlier, where I showed you how you can make a mass form and then intersect it with the different stories of your project. So let's go over to page 10. Okay, so the next file that I'm going to open here is the in the session 4 folder. I think it's called, oh yeah, massing on structure. So top of page 10, folks. Massing on structure. So what we have here are some glulam beams and some, and they're on different planes. So this is a real project where the designer wanted these glulam beams placed, and now what we needed to do is try and build a roof object that would follow the shape of these beams. Now, they're not all at the same elevation. So trying to model something like this with your regular Revit roof tools would be impossible. Trying to do an in-place family on this, what are my points of reference? How do I use just my beams to try and get something that I can work with? So, folks, let's do an in-place mass family. So you've seen how to do it from the component tool. You can also do it from massing in site by just choosing in-place mass. So this is another way that you can get an in-place mass family. You can do it massing in site, in-place mass, or you can do architecture, model in place, and then choose the mass category. Either way. Not worried about the name of the mass, so just hit OK. So again, we're back inside the massing tool set. Now for this whole process that we're going to talk about here, the very sort of practical applications of massing for just regular construction purposes, we're going to use reference lines always. You have to use reference lines for this mode. So instead of choosing model, you must choose reference. Now, this is where a cool feature of these reference lines comes into play. You can 3D snap. So if you can see something on your screen You can just 3D snap to it, and your reference line will follow it. So what we need to do is create a surface onto which we can create a roof that will follow our beams. So you've got 3D snapping enabled, you're using reference lines, and all we had to do to create this sort of lily pad roof that was being built on this building was to zoom in and find the middle top of each beam and go from it to the middle top of the next beam, and going our way all the way around to the end of the beam, midpoint of the end. Don't worry about Revit if it says it's not quite right. It's fine. It's just not a 90-degree angle. We know that. So it's still browsing. Because somebody legalized marijuana early, and that's how this thing got built. So we just keep working our way around the outside here, following the midpoints of our beam ends at the top center until we've got a perimeter. So just follow it all the way around. And ignore any errors that Revit throws your way. So when you are finished, you will see this. You'll see a series of reference lines that wrap around the outside of the roof to create a continuous perimeter. I'll give you a couple minutes more and we'll wrap it up. Okay, so because we've used reference lines now, Revit will give us the option for when we create a mass form. So now we just put our cursor right on top of this, and we go up and we choose a form. Now, when we do this, Revit's going to give you two options: to create a solid or a surface. So what we want is a surface. So now what you get is, instead of solid geometry, you get a surface geometry. Now, I'll be honest here, I've actually simplified this process. What we had to do when we built this roof is we had to actually follow each one of these beams. So we had a reference line that went down the center right to here, and we basically drew out each of these zones. So there's a triangle here, a rhomboid here, rhomboid, rhomboid, triangle, rhomboid, rhomboid. So basically we had to trace each of the tributary areas around these beams. So that when we were done, instead of the triangulation happening like you see here, each one of these planes was its own separate definition. But that would have taken more time, so I skipped that step. So our mass surface looked a little different than this. It was a little bit more complicated. But the point is, we're done. So we can hit Finish Mass. Revit's telling us that there's no solids here. This error is telling us that there's no solids. It's just a mesh. It's a surface. But that's okay, because the point is that we want to use our regular good old roof tool and do a roof by face. So what we want to do we've used the massing tools to define surfaces defined by these beams onto which we can glue on a Revit roof object. So we choose roof by face. So now you can choose, whatever roof type. If you're going to just use decking. So I think what happened here is that there was, I can't remember if it was plywood or decking that was put on top. And the decking, of course, was just nailed into the beams, so it followed whatever plane was there. And then you just trimmed it off on the edges. So I'm just going to use the wood rafter here. Doesn't matter which family you use. Now pay attention. Once you've got your massing in place and you're using the roof by face tool, is the face at the top? These faces that I'm choosing right now, is that the underside or the top of the roof for my decking? It's the underside of the decking. So instead of picking faces at the top, I've got to switch this to faces at the bottom. So when you're using the roof by face mode, you're telling Revit whether the face that you're choosing is the top or the bottom of the roof. In this case, it's the top of the structure, but it's the underside of deck. So I'm choosing faces at the bottom of the roof. So I just put my cursor over one of these pieces, click it, and I'm just going to do just this wing here in one go, and then hit create roof. Okay, so it doesn't want to do it. Let's try it again here. Sometimes you just have to do it one at a time. Now, as you can see here in particular, the roof is not properly following the, oh, and I did it wrong. I chose, gotta love teaching. After all this noise about choosing faces at the top of the roof, I still did it. So it's faces at the bottom. There we go. There we go. Now we've got coverage. Good. Anyways, you can see the point. These massing tools can help you, especially with roof geometry, to solve some of the modeling problems that you just couldn't otherwise accomplish. So if you're doing timber structures, especially something like this, which is kind of like a West Coast sort of Denman, Hornby Island style construction, stuff that Blue Sky would build, or one of those other firms, designers here on the coast. This allows that kind of geometry to be easily placed on top of what frankly is easy structure to put up. It's easy to put those beams up at different elevations. It's just hard to model the roof that would go on top of it. So by using the massing tool set, we can build that geometry on top of these roofs. So that's one example. So there's another example I want to go through with you folks. And this is the massing on steel roof framing. So if you folks want to open that one up now. Now instead of a nice sort of organic structure that's nicely harmonized with nature, we now go to the horrible concrete and steel tilt-up structure. And again, we're solving a similar problem. So this is massing on steel roof framing. So same idea here. Any of you who are familiar with tilt-up construction know that what often happens is that you've got a parapet at the edge of the tilt wall, and you have pockets in the tilt wall in which your roof joists bear. So there's a pocket formed, the roof joist at the edge of the wall sits into that pocket, and typically it's the same elevation all the way along. Not always, but commonly it's it's done. Now we don't bother modeling those pockets when we're doing tilt construction. But to get slope to drain, what they do is they typically, and you can see it here on the inside, the structure is sloped so that you have low column, high column, low column, and there'll be a roof drain by the low column to collect rainwater that runs on the roof and is collected at these drains. Same idea. Now, last week we showed you how you can take structure and you can 3D snap from the edge of the roof to the center beam, and we showed you how you can use a little small HSS tube that you can model around the edge, and you can 3D snap your joist from that little tube that won't show up in your drawings because it's so small, and then bring your joists over to bear on the structural beam at the center of the building. Now, how do you model a roof that's level on the edges but sloped down the middle? Well, you can't do it even with an in-place roof family. That would be very difficult. But massing makes it quite easy. Now, what I've done is I've got the start of a massing family sitting out here. There's a little model line that you can select so you can go back and edit the massing family really easily. So now we're back inside it. So same process as I showed you moments ago on that wood frame example. We use reference lines and we trace each bay. So we go from the edge down to the center of the column with 3D snapping. And then we go out to one of our joists where we have a break in the beam. So you can see here there's one beam here, comes down to the column. There's another beam here that goes up to the other column. And I just took a reference line and I 3D snapped from the end of my beam to the end of my beam, followed the joist out to the edge of the building, and drew reference lines around each bay. Those have already been drawn for you, so you don't need to do that to do this example. So what do we need to do? Well, we need to create mass surfaces. So you can see on the right-hand side, those have been done. So let's give it a go at doing the left-hand side. Put your cursor over one of these reference lines, and you can see it's selected, so that's great. So we click it to select it. But now we've got to select the other three in this bay. Now when I put my cursor on the next one, it wants to grab the whole line. I don't want the whole line, I just want that one. So I hit the tab key, and then the control key to add it to the selection set. So now I've got two reference lines selected. Hover over the next one. I don't want all of them. Hit the tab key. Now control click it. Because if you didn't control click it and I just clicked it, it would select that one and deselect the others. So I have to hold down the control key. You can see the little plus on my cursor. Whoops, tab, control click. Finally, the last one. Didn't select any others, so I'm good to go. Control click it. So I've got these four reference lines selected. Which I'd created earlier. And I'm good to go. So again, I'm not making a solid, I'm making a surface. So you can see Revit gives me the two options of making a solid or a surface. I'm going with the surface option. So I'm making surfaces anytime where I've got a break in the structure, and I'm going to skin a roof onto these massing surfaces. So again, just so you can see how I created it from scratch, I'm going to delete these reference lines down at the corner here. So I'm going to delete that one, and it's deleting that mass there, of course, because those are based on reference lines. Right, so I used reference lines initially. So here's what I did. Found the center of the column right there, and with 3D snapping, it really is a cinch. I just picked the center of the column, and I went over, found the end of my open web steel joist, snapped to it, come along on the corner, orbit the model around, go into the corner, right here, and it'll snap, come along till I find the middle of my beam, snap to it, and then finally come back and finish where I started. Looks like I might not have started at the right point, but you get the idea. There. So what you want to make sure is that all of these reference lines are all interconnected. So once you've done that and all these reference lines are interconnected, Revit can create a surface. So errors that can happen. You have to make sure that your reference lines are all meeting. If they don't meet, if you don't create a closed path for those reference lines, Revit can't create a surface from an open shape, right? So if you ask Revit, you know, to, so here if I use some reference lines and I make a path, but I don't quite meet at the corner, Revit can't create a surface from this. So if I go in here and create a form, see what it did? It did it the other way. It created vertical surfaces. So that's not what we want. So make sure that your reference lines close. And once that happens, then you'll be able to make a shape that you can then make a mass surface out of that. Okay, so I'm not going to make any more surfaces here. I'm just going to finish. So this is very similar to the process we looked at just a few minutes ago. So we're going to finish the mass, use the architecture roof by face tool. And again, this is the underside of the deck. So the roof object that you would create, or the roof family that you would create, would be your decking and your insulation and your roof membrane. So if you have 1.5-inch deck and then maybe 7 inches of rigid insulation, and then whatever membrane you're choosing to go on top of that, that's what you would define as your roof type. So whatever you've got in here for a roof type, I don't think I've got anything kind of appropriate here. So again, the faces that you're picking are not at the top, they are at the bottom of the roof. Now I don't think I've got enough freeboard here at the edge because I think this building wasn't heated. So we're going to end up with, the roof is probably going to shoot up above the edges of our parapet here. But again, faces at the bottom. Pick one of your faces that you've defined, create roof. Yeah, it's too high. Create roof. And you just keep on going. And you create all the different roof objects that you need at each one of those mass surfaces that you've created. So this can take a lot of the ugly legwork out of what really is a very cheap and nasty building. Tilt-up is quite inexpensive, but as you can imagine, trying to model these roof objects with some other workflow, don't really know how you would do it. Okay, so I am done with the lecture part tonight in terms of what we're going to be talking about, so I'm just going to stop the stream.